Okie dokie. Well, as promised, here's the science homework that we had discussed today. Okay, so this is where we stopped. We are on the fill out the chart concerning states of matter. And so, a solid, does it have a definite shape? Yes, it does. Does it have definite volume? Yes, it does. Can it flow? No, it cannot, because you're describing the movement of the particles. No, it can't flow because it is fixed in place or rigid. It means it's tight, tightly compacted. So if you can see that right there. So how close are the particles? And here's the picture. So I'm going to just draw a picture of, I'm going to put a little box here. And inside my solid, I'm drawing the little molecules. And they're closely compacted as a solid. So they're fixed in place. They're not going anywhere. They're not going to move. If you heated it, they'll just shake in one spot. They're not going to go anywhere. Okay. Now, the amount of energy that it uses. Does a solid use a lot of energy? No. It's going to just be in one place. So that's really the third. I guess we could have saved that one for last. But that's what we're needing to know. Okay. Now let's look at liquid. We're doing the same thing. If you need to pause it, just pause. I think I'm going to sneeze. Sorry. Liquid. Definite shape? No, there is no definite shape, because remember, when you put a liquid in a container, it's going to take the shape of that container. Liquid takes shape of the container, and also it starts to fill the bottom of the container as it increases. Does it have definite volume? Yes, it does. Because once it's filled, if you put in 60 milliliters, then that's the volume is 60 milliliters. Can it flow? Yes. They slide past each other, so those molecules can flow. They slide or move past each other. Okay, so for liquid, that's a T. If I use this whole thing, this part here, as the container, then my liquid is going, it comes to the bottom, it will fill the bottom of the container, and so they're here. They're looser, they're not as tightly. Okay? And we'll come to this one, the amount of energy it takes. Let's look at here. Definite shape, a gas. Nope, a gas does not have a definite shape because it will fill the entire container. And on here, I'm going to just put over here to this side that it will that the liquid will fill the bottom of the container. Just when you're pouring it in, it fills that bottom and then takes the shape of it. Okay, so gas, no, it will fill the entire container. Does it have definite volume? No, it does not have definite volume. It is very compressible, which means that if you were to push it down, think of a balloon. Think of a helium that's inside a balloon, or even your own, the CO2. When you blow into a balloon, you're blowing out CO2, and you can move that gas around inside a balloon. So you can squish it down and move it in direction. So it is very compressible. Can it flow? Yes, very much so. It moves around quickly in the space. And so when I draw it, we know that it fills the container up. The amount of energy that it uses, it's using more energy. This one uses the second most and then less energy. Oops, I'm sorry about that one. The gas uses the most energy, amount of energy. It has the most, then it's second for the liquid, then it's third for the solid. Okay, pause it if you need to. The next one, on the back here, it says Kate and Aruda are given a baggie with sawdust, baking soda, flour, and iron filings, evenly mixed. List the tools and the methods you can use to separate the three substances. Okay, so if we wanted to separate these, I am looking at that there's sawdust, baking flour, and iron filings. Immediately, I know that I can take, yep, I hear y'all yelling it out, use a magnet to separate the iron filings. Okay? The next step is, what would you do next? Okay, so we have sawdust and baking flour. Okay, well, I know that if I have my sawdust is made out of wood, so I can actually put the remaining mixture in water. Okay, because one thing I'll know is that sawdust is going to float. And because I know that it's less dense than flour, I can scoop it out. And then what's left is just the water and the flour. So I can do one of two things. I can evaporate the water, or I can also pour the flour and water mixture through a coffee filter. Okay, so the flour will stay behind on the filter. And the water will filter through or percolate through that. So yes, you can do this one or evaporate the water. Okay, let's look at the next one. We're given a wood block. We said that it's a solid, it's non-reactive to magnets, floats in water. Looking up here, a metal block. It's a solid, sticks to a magnet, sinks in water because it's more dense. It's metal. Dr. Pepper, it's a liquid, non-reactive to a magnet, it's not magnetic. Evenly mixes with water because it turns into one solid color. And most of you, if you like Dr. Pepper, you think it's delicious. This is an opinion, not a fact. I'm not a Dr. Pepper fan, but that's okay. Nitrogen is a gas, non-reactive to a magnet, floats above water because it's less dense. White crystal, it's a solid, non-reactive to a magnet, evenly mixes with water. Okay, that's that white crystal powder drink. And then you have purple crystal. It's a solid, non-reactive to magnet, evenly mixes with water. Okay, so with this information, after collecting the data on the physical properties of various objects, Manessa and Sidney realized that there was one property that would separate the items into groups that had the same number of objects in each. Which property do they plan to use? Okay, I'm thinking one got mixed up here. Okay, because we did this one in class, and I think one got mixed up here. So we had, let's look at this one. This one actually, because I'm looking over here after collecting the data on the physical properties. So which one do they plan to use? Okay, so I can understand where this kind of got mixed up. Because there was... Okay. So this one here goes to a different one here. And this one, okay, so you're going to be actually confused. Because this goes with this here, but somehow it didn't get together. I don't like it when that happens. It's so confusing. This one was a magnetism. So after collecting all this data here, it says on this physical properties, Manessa and Sidney realized that there was one property that could separate the item into groups that had the same number of objects in each. So, do each of these have the magnetism that they can be separated? No, so we can't use that. The next choice is the state of matter. Solid, liquid, and gas. Can they be easily separated? Well, they each have those, but it's not going to be easily separated. Because here's a solid.